Samara, and I'm here to talk to us about hygienic design for food equipment. I'll quickly introduce the topic and we'll look at the possible outbreaks, the basic principles, and then I'll summarize. The International Standard Organization and other international regulatory bodies, just like the European Hygienic Engineering Design Group, has set up an international standard requirement every manufacturer must strictly adhere to when designing a food equipment, especially those part of the equipment that may touch the food in any means, intentionally or unintentionally, and be it condensation, drain, splash, or drop into the food, must comply to two basic criteria. One, protect the food from contamination and possess high cleanability properties. The moving parts of the machine must be safely guided in order to avoid injuries, and it must be durable. That means not easily worn out. And with all these criteria, it should also be able to perform its optimum duties. Let's look at the outbreaks associated with these poor designs. In 1994, in US, there was a Salmonella outbreak in ice cream, and this was investigated to be caused by a contaminated tanker truck that was not properly cleaned after conveying unpasteurized eggs. In 2008, there was Listeria monocytogenes outbreak in dairy food, in dairy meat, in production in Canada, and it was revealed to be caused by contaminated meat slicer that has uncleanable surface and stress traps. And also in 2009, there was a Salmonella typhimurium outbreak in peanut products, and it was seen to be caused by poor sanitary equipment design. And lastly, in 2011, there was Listeria monocytogenes outbreak in cantaloupe, and it was revealed to be caused by uncleanable design. Because of time, I'll be looking at 5 basic principles of when designing a food equipment. 1, it must be inert, in the sense that all surfaces in contact with food must be non-toxic, corrosive resistant, mechanical resistant, and non-absorbent. And there should be in no way the compounds of the material migrate into the food or modify the food product. And the European Hygienic Engineering Design Group recommended stainless steel and polycarbonate. 2, it must be all surfaces in contact with food must be smooth, polished, and not porous, in order to avoid building up of small food particles or bacteria inside eggs in the surface crevices. And also, when undergone microscopic analysis after cleaning, there should not be any food residues. 3, it must be accessible. All surfaces in contact with food must be accessible for inspection. It must be easily disabled and assembled in order to achieve effective cleaning. And for liquid products, equipment like tanks, it should have a clean in place unit in order to achieve an acceptable hygiene and sanitation. 4, self-draining. This is very, very important for liquid products in order to achieve easy cleaning and also to avoid microbial growth. For example, all the pumps we have parastatic pumps, diaphragm pumps, and so on. And 5, like I said earlier, you should be able to protect the food from other parts of the machine and also from external contaminants, and also for easy draining and operation. In conclusion, the equipment that are able to achieve these requirements is very easy to maintain, to clean, and also to decrease contamination of both physical, chemical, and biological. These are my references. I would like to thank Dr. Michael Ngadi, my reviewers, and the TA. Thank you very much.